Hello everyone, this is Reza and today I have another exciting effects tutorial in Maya using Bifrost extension. We are going to use Bifrost to create clouds. We've already published some videos on Bifrost plugin on this channel, but in case if you have missed them, Bifrost extension is a node-based framework for building custom effects such as pyrodynamics, sand, snow, and many more. You can preview the result directly in the viewport, and of course you can render them using Arnold inside Autodesk Maya. I put some links in the description if you wish to review an introduction to Bifrost Aero video, but for now let's dive right in and see how we use this amazing visual programming tool to create a volumetric cloud. All right, let's dive right in. I'm going to go to Windows, Setting Preferences, and Plugin Manager. Need to make sure that my Bifrost plugin is successfully loaded. That's all good. Then I'm going to go to Windows and bring in my Bifrost graph editor. Right off the bat, I'm just going to dock that right in here. Well, you may have noticed I can actually create a graph right off the bat, and again, these are the things that I do discuss in our introduction to Bifrost Aero video. But what I want to do is to have a model in the scene and create my graph from it. So basically I want my input node to be linked to whatever object I'm creating automatically. It's actually very easy to do. I'm going to go to Create. I'm going to go to Polygon Primitive, and for this particular example, Volumetric Cloud, I'm going to use just a normal cube. I think that works the best. I'm going to increase its size a little bit, so 5 in X and 5 unit in Z. I don't want to increase Y value because, well, unless you want to create a very thick cloud, that's not something that you aim for. All right, I've got this. I'm just going to call this cloud_geo. And while this is selected, you can go ahead and create graph. Now, on the surface, it's not very clear what just happened. You can go, all right, input to output, what's happening here? But if I go select the input, you can see Cloud Geo Shape has been connected to the Bifrost Graph 1 node that I just created. So this is a Cloud Geo object. If I right click and enable shapes to get to the shape node, this is the node that has already been connected to my input. That's a really nifty trick. Rather than dragging and dropping and creating an extra node, you can actually link your input into the model that you are selecting as well. You can have wildcards, for example, // selects all supported geometries in the scene, and you can sort of manually apply geometry to your input node. Very similar to how render layers work, that you can just use wildcards and select multiple objects. But for now, we're just going to continue with what we have. All right, this is connected, so it's all good. I can right click and disable shape node, have a much tidier outliner. And now let's see how we can make use of this object or mesh to create volume. Every time you would like to convert a mesh to a volume, you need a compound called mesh to volume. Very straightforward. I can press tab and type in mesh to volume. That's the compound you use every time you want to convert a mesh to a volume, and basically turns your geometry into a bunch of voxels in a much simpler term. So from mesh to mesh, and from volume to mesh. Now let's see what we have achieved. If I hide my geometry, all of a sudden I see something. Now don't worry about that black color. Again, that's the beauty of Bifrost extension. You can actually see objects in the viewport, and objects do react to lights. As soon as I put in lights, then I can see it. So don't let this gray halo distract you. Let's go through some important attributes that I do take a look at every time I convert my mesh to voxel. So I think one of the important ones would be volume mode. We have solid and shell. The explanation is very straightforward. If you have a solid interior like this box, you leave it as solid. But if you have a surface with a hollow interior, then you switch from solid to shell. Now, sometimes you would like to store your information in fog density, which is useful for smoke or dust. But in this particular scenario, I would like to store it at level set. And that gives me a much thicker result. And that thicker result helps me to create effects like cloud. So that's done. I'm going to scroll all the way down to go to resolution. I tend to set the resolution from relative to absolute. Absolute works with world space units and gives me a kind of much tighter boundaries around my input node. Gives me somewhat more accurate result. And detail size, kind of fill those gaps and get the boundary even closer to my volumetric input. Basically, as an analogy, it's like reducing the particle size in particle simulation, where lower number gives you higher resolution. That's pretty much the same deal. I'm going to actually increase that a little bit because we are previewing at the moment, and that gives us a little bit of gap around the edges. Slightly less accurate result, but it's good for now because, well, we are still putting together the main building blocks. We don't care about super high resolution. We can do it right at the end. Okay, so that's good for this chapter. We learned how to convert mesh into volume. Let's see where to next in the next chapter. Now let's continue. We have a voxelite mesh. Let's see what we can do with it. I'm looking at the channels that I have available, and both in and out, and there's not much to play around with. What if I want to add fields? What if I want to advect fields? Well, you need to actually create a field out of your volume geometry, and that gives you simply more control. The node to do that is you just go Voxel Field, and that gets an input from your volume and makes it available to have more inputs like vector field or scalar field to add a little bit of motion, make the movement more interesting, make the shape look more interesting. So it's not going to be just a rigid cube which you have voxelized. Now, the catch to that voxel field is you need to be careful about the output port and think about the color. Now, look at the color, and if I go and get the output port and try to plug it into the input of my output mesh, you can see I'm getting an error. It simply says that this is not compatible and this output node is unable to compile the result. It kind of makes sense as well because we had a volume and this expects to receive volume, but we just created a field out of volume. So that is not going to work. We need more, something else right in the middle to be able to view the result. Well, think about it. We converted mesh to volume and then we created a voxel field out of that volume. Well, we need to convert it back. I'm just going to press tab and I type in field to volume. You can see once you understand the concept and the logic behind it, it's actually very, very straightforward. So it accepts fields, of course, that's why we're having this node. And now you can go from volume to mesh and we get our volume back. Now, the only thing that is a problem, I'm not sure if you guys have noticed, we had such a kind of crisp looking volume object when we converted our mesh to volume, but we are getting that sort of fog density looking back. So we need to kind of take care of that right off the bat. So I'm going to go to field to volume. I'm going to scroll all the way down. Let's sanity check everything. So volume mode still set to solid. Now resolution needs to be set back to absolute. That's what we had before. You may say, Reza, why it looks so faint and why you didn't use store level set just like we did in mesh to volume. Well, you can, it's just going to make the result too crisp, for lack of better word. So if I turn off store fog density and turn on store level set, we are doing this twice and it gives us a very, very sharp looking volume, which may not suit well when you think about clouds. There's always a degree of softness around a puff of cloud, so be kind of careful about it. Of course, if you're going with a super stylized look and if your reference or project is asking for it, then you can apply that. For realistic looking cloud, I think one round of level set will get the job done. I'm just going to go and select the store fog density this time, and I can just simply increase fog density that way. Now, you can still scroll all the way down and reduce or increase the detail size as well. I'm just going to leave it as that. Actually, I set the other one to 0.1. I'm going to set this one to 0.1. That gives me a degree of softness, which may not be what you want in other scenarios. For cloud, I can live with that. It's acceptable. All right, let's go to the next chapter when I talk about an alternative to output node. This output node works for us. There's nothing wrong with this poor guy, but recently Bifrost released a new node as an alternative, and that node gives us more control over how you see your simulation, how you diagnose your simulation, and how you render your simulation. Now, the node that I'm about to use is called terminal. Terminals are alternatives to output nodes. That node or that compound gives us more control. Let's just bring it in so we see what we're dealing with. Just going to go terminal. Now, right off the bat, you see a big change in the look, right? So this terminal node has got three functionalities. Final, which is for final offline render, high resolution stuff. Proxy, which is for viewport display, and that's probably what we're going to use for viewport display, so we can see sort of low resolution geometry. Normal computers can handle it, and by default you cannot render them. So if you plug that to your proxy, you can only see them in the viewport, but you cannot render them. To render them, you have to switch from proxy to final. And then we have diagnostic, and diagnostic is, you know, for special geometries that you would like to create for a very, very specific purpose. For example, to voxelize property values as colors. Sometimes to troubleshoot, you use diagnostic, but on a normal day for normal use, I basically toggle between proxy and final. Now, here's the thing. You can connect this node to all three. And you may say, well, if that happens, how does this node know which one to use? With the help of these buttons. So in this case, I would like to render it as my final. I would like to look at it in the viewport as my proxy, and I may or may not want to use, but I still would like to have that option. What makes these activated or deactivated is these buttons. So I'm just going to go and say, I don't want final at the moment, and I don't want to calculate or compile any diagnostic calculations. I just want to look at the proxy. All right, that's good to go. I probably going to end this chapter here. Before I move to the next chapter, let's actually create some lights. I'm just going to create, let's say, a directional light. Where did that go? It's right in the center. I'm just going to move it around. So I'm just going to make it slightly bigger so I can see what I'm dealing with. Rotate it slightly in Z-axis and in Y-axis, and of course in X-axis. Maybe bring it slightly lower and around so I can kind of see it better. Something like that should do the trick. I'm going to go to Attribute Editor because right now I'm not going to see anything. I can enable this Use All Lights in the viewport, and instantly you can see the volume gets slightly brighter. But again, what you can do is to just increase the intensity and you get some of the information, the color information back. You can of course use exposure in Arnold as well, bring it in. But for now, I think a value of 3 should get the job done. Probably I'm going to add point light as well. I'm going to move it up a little bit. And I'm going to intensify the intensity value so I get a better sort of look here. It's not just too dark, and you can see I'm getting all the shadow information, so on and so forth. All right, with that, let's actually go to the next chapter and see how we can improve on what we have right now. Next up is to improve the shading quality of what we have. Well, it looks good, but and I'm not going to render it too early, but we can actually improve on the look dev early on just to get a much more accurate representation of the volume. And while we are actually building our graph, we can actually incorporate that into our graph as well. And again, these are the strategies that I covered in depth in my Creating Fire with Bifrost tutorial, but I am going to go over a few important attributes again. With that said, I'm going to go and open Hypershade, and I can go to Arnold, Shader, I can expand that, go straight into Volume and bring in aiStandardVolume. Just going to arrange that a little bit. Again, we talked about this before, but in case if you're new to this node, aiStandardVolume is a physically based volume shader, which is just a perfect fit for our example because it allows the the color and the light to scatter. It has transparency value, and it's great for physics simulation. So I'm just going to name it really quick. I'm going to call this aiStandard_cloud, so we know what we're dealing with. Right now, the attributes that we have doesn't target fog density, and that's what we used in our simulation. So you need to make sure that voxel fog density is selected, not just density. One way is to do everything manually and get it to work, which admittedly is not really a time-consuming task. Another way of doing this is this beautiful preset actually does provide us with a few presets, and one of them is default Bifrost Aero, since Bifrost Aero predominantly works with voxel fog density, so why not we use this as our starting point. So I'm going to go replace And indeed we have voxel fog density ready to go. This setup is not just a one-click solution. You definitely need to look at this as your starting point, not the final look, but at least it gives us the right attribute to target. Now we already have this. Let's see how we can kind of bring that node into our node graph. So all you need to do is to drag and drop your node into your Bifrost graph. I'm just going to drag and drop the node here. So I have AI standard cloud. Of course, I need to bring this a little bit further. You actually don't need the output node since we have the better alternative terminal. I'm just going to get rid of the output node and I'm going to unplug diagnostic because I'm 100% sure I'm not going to use diagnostic. Every time you bring your AI standard volume shader, just make sure that the right name is attached just in case. Sanity check it. Let's assign that to assign material. So assign material, and then this material reference goes to volume material, and then geometry goes to volume, and we can just unplug those and go out geometry, one copy to final for rendering and another copy to proxy so we can see it in the viewport. Now just to demonstrate and basically to sanity check this and to make sure it's working, if you go, hopefully you guys can see what I'm doing. I've got too many windows. On a normal day each gets a monitor, but right now I try to fit all of them into one monitor. Probably move this guy here, that's better. So just check, make sure the connection is there. So if I go and just color the cloud red, which is insane, you can see the red color. Just a quick test, make sure it's working. Going back to the color it was. Now going through a few of these attributes. Density probably is quite important. Low density gives you thin volume and high density makes the volume thicker. I think best way to put that into practice is we'll leave that for later when we have the actual shape of the cloud, and then we can revisit this AI standard cloud and tweak around with it. For now, I just wanted to have that set up so we have, you know, everything shading wise ready to go, and then we can just when the time comes we go back to it and we tweak it further. With the node selected, I can press L to make the graph tidy and organize. Let's move on to the next chapter and break up the look a little bit. All right, next is to basically get rid of this boring looking cube that we've been staring at for too long. It's time to bring in some excitement into the mix. So I am going to make some room in here, move them to the side. By the way, in between sessions I went ahead and just increased the intensity a bit more. So it was 1, I set it to 5, so it looks a bit brighter. Let's see how we can kind of change that voxel field that we've created, and let's see how we can bring in more patterns so it looks like actually a cloud, not a cube. Well, we have voxel field and we already know the role of this node, but this voxel field by itself doesn't do much. It actually provides an opportunity to advect field. Well, to advect field, we need to bring the node. What's the name of the node? Advect field. Simple as that. We go from field, voxel field to field, and advected field into field. Perfect. Now, what is the role of advect field? It actually advects a scalar or vector field along a velocity, and if I zoom in, we have a channel for a velocity field. If I click on the actual field, you can see we already plugged that to the voxel field that we have right here. but the velocity is something that we need to add. For this particular example, we are going to bring a vector field, and many noise nodes will fall into a vector field category. Now, the one that I tend to use the most is called fractal turbulence field. I can have that, and this is now a vector field. The noise output goes into velocity field. Now, this will advect along whatever we specify for this noise. So let's see how we can make it work. With Advect field, we have time step. Now, if I set this to 1, you can see instantly that we are getting some deformation, or rather distortion, in our volume. I'm going to go to mesh to volume and reduce my resolution to something like 0.04 maybe, just to get a much crisper result. I think that the resolution was a bit too low for my taste. Now we want to kind of develop the look a little bit. I'm just going to enhance the resolution. Cool. Let's go back. I'm probably going to move that window up just a tad to make myself more room. Cool. And by the way, those tabs are collapsible. If you think you're not going to see them or you're not going to work with them, you can easily just collapse them and save some space somehow. I'm going to do that with Advect field as well. I'm going to press L, make everything look tidy. With Advect field, I believe that value of 2 or maybe 2.5 is a good value. What I'm trying to do here is to get the main look with this vector and turbulence, and then enhance the macro details later. Right, so that's the idea that I have in mind. Let's see how we go. I'm going to go and select the fractal turbulence node. The first one is magnitude, which is a no-brainer. Magnitude scales the output field. It intensifies the effect. So 1.5 will get the job done. You can see instantly we're getting some interesting shapes. Number of frequency, it's just the total number of the curl noise frequencies. So you can set this to 1 and it softens your cloud, and you can increase that and it kind of gives you a more curl noise within your cloud. I don't know, something like 3 or 3.5 would give me a good starting point. I'm not worried about the details, as I said. I will get to that later. I just want to block out the shape of my cloud. This frequency is important. It's the base frequency, and that changes the look of your cloud significantly. So I can set it to 1. You can see you get a completely different look, and the default was set to 0.5. I can set it to 0.1, and you can see you basically remove the deformation or distortion from your cloud. So what does this tell you is higher values will give you finer details. So I'm going to probably enhance it to 0.6 at this stage. I'm not going to be too worried again about the details and probably the shape. Ratio is the ratio of a magnitude of each curl noise. So when you increase this value, subtle details look more visible. Just for example, if I set it to 0.8, all of a sudden you see I'm getting more puffs and droplets around my cloud. So it kind of intensifies or magnifies the small details in your cloud. I'm going to set that to 0.7 for now. I'm not going to get too excited. Okay, now I'm relatively happy with what I have. I'm going to basically hide my grid. It's a little bit distracting. I'm going to select this bit and leave a little bit of room for myself. Now here's what I'm going to do. I'm going to actually copy and paste these two nodes one more time. Now you probably see where I'm going with this. I'm using 1 just to create macro details, and I'm using another one just to kind of block out the main look. I'm gonna expand these guys so I can connect the right channel. I'm gonna go from field to advect field and field to advected field. So as you can see, we kind of multiplied the effect, and that's probably not something that we want, but that's okay. We did it intentionally, and we know we are going to change some values in the secondary field. So I'm going to rename this just in case. I'm going to call this advected field. I'm going to do the same thing for my turbulence field. I'm going to go turbulence field, major details, and in here minor details, so I know every time I select my advect, I know which one I'm selecting because I'm looking at the name right here. Now let's go through the second one and see how we can polish that. I'm going to definitely bring the time steps down to something like, I don't know, 0.3. Yep. So to vacuum everything back again to where it was. And now we're ready to introduce more details into this. So I'm going to select the minor detail fractal noise, and starting with the magnitude. Well, I used magnitude for major detail fractal noise. So I'm just going to lower it for minor detail fractal noise. We don't really need it as much. Number of frequencies can definitely go down as well for the minor, and it kind of pulls everything back to where it was. Now, one key attribute that actually adds detail in here is frequency for the minor detail. So I'm going to increase that to something like 6, and all of a sudden we get a lot of details coming in. So if you compare the original value, which was 0.5, and 6 or even 8, you can see we definitely add more information in, which is very, very useful. I'm also going to reduce ratio as well to kind of intensify some of the minor details, small details as well. Now, the overall look I'm actually quite happy with, but let's go through one last chapter where I give you a really nice hint on how to get the exact shape that you want with your cloud. I'm not talking about details, I'm talking about the overall shape. So we're almost towards the end of our session. Before I go to the shape, I'm gonna go and tweak some of these attributes in here, because we basically made a promise that we revisit this window, not to just leave it as is. It's not actually too bad. I can actually reduce it just a little bit, right? And instead we increase scattering. Now the weight cannot go over 1, but if I go to color into value, I can definitely increase the amount of scattering that is happening here, which is pretty good. So that is better. I mean, it looks like a cloud more, if I may. Now, to shape the cloud, here's an interesting tip. Instead of going through different nodes in here, you can actually change the shape of your cloud geo. Because everything is done procedurally behind the scene, you can actually interactively change the shape of your cloud. So if I go in here and say, all right, I want scale X to be, I don't know, 6, scale Y to be 2, and scale Z to be 10, all of a sudden we get a rectangular looking shape. And here's the interesting part. You can actually go in there and animate this. So I can actually keyframe scale Z if I want and say, well, I can have more or less, right? You can even go into frame 100 and keyframe these guys and say, set a key, and go to frame 1 and zero them out, and you get a situation where you now have an animation that the cloud is appearing gradually. Very, very cool. Now I am going to create another how-to video on how to create a for each loop so you can multiply these puff-of clouds randomly, but you can actually put those clouds on a layer and render them separately and comp them back in post using Nuke or Fusion or whatever software that you're using for your compositing solution. But if I were to render this right now, I can just go into Arnold and hit render. Now remember, if you are rendering this, I'm just going to nudge that one back into the scene. If you are rendering this, you need to make sure that the render or the final terminal is enabled. We talked about this already. So make sure the terminal is enabled so you can see it in the viewport. Otherwise, you have to go and manually change the terminal tab via the attribute editor. So that should do the trick. Just to clean up, I can go in here, I can select my graph and press L. So in case if you want to share it with someone else, that person knows what you're doing, I can select these guys and move them to the side and select these four, and just with those four selected, I can actually go full screen so you guys see what I'm doing. You can select these four and just create a backdrop for it. So when you move your advect fields and your fractal turbulence, you move them all together. There won't be any confusion on that. You can also select the field to volume. I'm just going to go to edit and bring my property parameter window back. And you can go in here and just reduce your resolution ever so slightly. With lower resolution, you get a slightly better result. And just look at your reference, look at what you need to create, look at your project brief, whatever your client is giving you, and fine-tune the look of your cloud given the attributes that now you know effortlessly. Okay, that should do the trick. That's enough for one video. I will definitely add layers to what we already know later, but for now, let's call it a day. You can support this channel via Patreon, you already know that, and you can find me on Twitter where I release more information, kind of talk about under the hood what we're doing and tutorials that that in the works. I hope you found this video useful. I hope you use it in your own projects. Let me know how you go. Until the next video, see you guys soon. Take care.